Okay, moving on to question 6. Again, 50 marks, and my email is on the screen there if anyone wants to contact me about the marking scheme with questions or comments. So, part A, the following diagram summarizes the industrial fractional distillation of crude oil. Okay. State what must happen to the crude oil before it enters the column. So it must be heated, vaporized, or evaporated. 3 marks for that. Very straightforward. Outline what happens to the crude oil after it enters the column, making sure to refer to how the fractions are separated. This is 6 marks, so any two. So there's a lot of ways marks can be gotten in that question there. So the vapor moves up through a series of trays. The fractions come off through outlets or off at levels depending on their boiling points. The higher boiling points come off at lower levels, lower boiling points at higher levels. The temperature gradient shown. So you can see there temperature gradient shown in the highest temperature at the bottom, lowest temperature at the top. You can see with these double slashes separates different points. Okay, the single one just give you options. Okay, so you must mention the difference in boiling points. Okay, and then how the vapor moves up through the fraction. So you can see your options there for 6 marks, where you get the marks there. Okay. What is the name of the missing fraction in box number 1? And give one use of bitumen. So the missing fraction is naphtha for 3 marks, and a use of bitumen is road surfacing or roofing or waterproofing. Many of the fractions contain sulfur impurities. Name an environmental problem caused by the burning of these sulfur impurities. So any one of these: deforestation, acidifying waterways, or corroding buildings. If you have any other options there you want to run by me, that's no problem. Heptane can be obtained from the catalytic cracking of hexadecane, C16H34, at high temperature. Write an equation for the catalytic cracking of 1 molecule of hexadecane to produce 1 molecule of heptane, 1 molecule of cyclohexane, and 1 other product, and name the other product. So C7H16, that's our heptane. C6H12, that's our cyclohexane, and C3H6 is the third product, and the name for that is propene. So 12 marks going there for your formulas, for 3 for your formula of heptane, 3 for your formula of cyclohexane, 3 for working out that it's C3H6, and 3 for naming that propene. Hydrogen-powered cars are said to be a solution for greener air and the environment. However, there are safety concerns surrounding hydrogen-powered cars. Outline why hydrogen as a fuel is said to be a solution for greener air and the environment, and name one safety concern that exists with the use of hydrogen as a fuel. So the reason it's a solution for greener air is because it's a clean fuel, it's environmentally friendly, and water is the only side product. So any two there for 2 by 2, just 4 marks. And a safety concern is that it's difficult to store or it leaks easily. Okay, so 4 marks for the safety concern. Onto our calculation. Calculate the heat of formation of ethanoic acid. Given that the heat of combustion of ethanoic acid is minus 876 kilojoules per mole, the heats of formation of carbon dioxide and H2O are minus 393 kilojoules per mole and minus 286 kilojoules per mole, respectively. Okay, so go through the calculation here. So first of all, you have your formation of carbon dioxide multiplied by 2 for 3 marks. Okay, so minus 786. Then we have the formation of H2O, again multiplied by 2 to give us minus 572. And then we have the combustion of ethanoic acid reversed for 876. So combustion of ethanoic acid is CH3COOH plus 2O2, giving you 2CO2 plus 2H2O, and we reverse that, and we come up with our final answer of minus 482 kilojoules. Okay, so the equations are not essential. Okay, however, having this as your final answer is worth 9 marks with that equation. Okay, which is the reversal of the formation of ethanoic acid. Final answer is worth 3 marks if it's accompanied by no equation. All right, so there's your option. So that's where you get the sign wrong for it. You can also do it using this method here. Okay, this is where the delta H of combustion is equal to the sum of the delta H of the products minus the sum of the delta H of the reactants. So you have your minus 786 plus minus 572 minus 876, and that works out to your minus 4a2. So either method is fine. 12 marks going for that for your full marks. Okay, so I think it's clear there where the marks will be going for. Anything you're unsure about or any questions you ask, send me an email. So that is question 6.